What did you notice when you expanded these brackets? Some of the numbers cancelled each other out. Which numbers cancelled each other out? The coefficient of x, and I love that you're using the correct language there, that's perfect. What we found when you expand these questions is that every time that middle term, that term with an x in it, always cancels out. What is going on in these questions that make that happen? What do we recognise in how the questions are written that might... There's a plus in one bracket and there's a minus in the other bracket. Right, so the first hint, there's a plus and a minus. What's the second hint? What's the second thing that's going on? Liam, thanks for putting your hand up. They're all the same. If I ever have a case where the two parts inside the brackets, or the two terms in my binomial, are the same, and one's a plus and one's a minus, what will happen in these questions every time is that middle term will cancel out. So when I'm expanding these, I can actually just use the shortcut. So I recognise, okay, it's x plus 2, x minus 2. They're the same. They're the same. So when I expand it, I'm just going to get x squared minus 2 squared, which is 4. Second one, x plus 4, x minus 4. This is just going to be x squared minus 16. Jump to the last one, number 4, 9x plus 2 and 9x minus 2 will just be 81x squared minus 4. If you recognise this, I know that middle term's going to cancel out, and I can just square the first one, square the second one. Okay, same as we did before. Freya, can you make up a question for me like this one? And I'm going to do minus 3. I'm not sure if he said minus. I'm going to pretend I heard a minus then. The second bracket would have to be 7x plus 3. It doesn't matter if the first one's a minus and the second one's a plus. They just have to be different. So if I wanted to expand the brackets here, square the first term, 49x squared. Square the second term is 9. Stick a minus between them. So 3 shortcuts. Shortcut 1. If it looks like this, there's no number in front of the x's. I can just square the x, add those terms for the middle part, times them for the constant. Second shortcut. This is what we call a perfect square. If we've got a perfect square, square the first one, then do the first one times the second one times 2 for the middle term, and then square the second one. And then the final shortcut, difference of 2 squares. We've got a plus and a minus, but the numbers are the same. Square the first one, minus the second one squared. What I want you to do now as practice is have a go at exercise 5A. While you are doing exercise 5A, see if you can use some of those shortcuts. All right? You have the rest of the lesson to do this. We may play a Blooket depending on how we're going. All right? Sweet.